everyone, welcome to Magaverse. Today I will be doing Leetcode 242 valid anagram problem. It's an easy level problem, and I will be talking about what basically an anagram is and how we can proceed with this problem. And later I will also be doing Python code on it. So let's get started. So anagram is basically a word which is formed by rearranging the using the original word letters exactly once. So as you can see over here, the A in this string, if you can see, A is 3 in number, N is 1 in number, R is 1 in number, and M is 1 in number. Similarly, if you see this string, it's just formed using this original word, and we have just rearranged all the letters of this original word. So this, if you see, A is 3, N is now 1, R is also 1, M is also 1. So if you see, all the letters are exactly the same, and we have just rearranged the letters, right? So both the strings, this string, we can say that T is the anagram of S. So this is a valid anagram. If we take another example, race and care, um, if you can see, this R is same, A is same, C is same, so it's also a valid string, valid anagram. If you see this one, this rat and car, you can see the C is not present in this. So this particular word is not formed by rearranging this using the letter of the original word. So this is not a valid anagram. So this particular problems, we have to find whether the string is a valid anagram of the original string, and if it is so, then we need to return true, and if it is not, we need to return false. So this is what question is, and let's see how we can proceed with this question. One of the possible solution to find the valid anagram is that this is the solution one we can think of, is that just by sorting both the strings and then comparing it uh, would solve our purpose, since sorting of S string would give you A, G, M, and R, and if you sort this also, this string, we will get A, G, M, and R. So if the after sorting, we just can compare both the strings, and then um, just say that if both the strings are equal, then return true, else return false. But this solution would we will be using Python inbuilt sorted function, which is basically, if you know, it by default uses tim sort, and it has a time complexity of O n log n. So let's say if your interviewer say no, we can't use this inbuilt function, and we have to give a solution which has less time complexity than this. So what can be the possible way? So there's another solution we can think of, is just by solution to is something like this. Like we can count each letter of this word. We can create basically a hash map of both the S string and hash map for this T string, and we can simply keep a track of all the letter of the word which are there, and the count of each letter of the word. So that's what we can do. Similarly, hash map of this we can create, and then we can compare basically whether the counts are equal or not. If each letter of the word each letter of the word is exactly same in count, we can simply say that it's a valid anagram. Time complexity of this this solution would be, because we are iterating through both the hash maps S and T, so the time complexity would be O of S plus T, where S is the length of S string and T is the length of the T string, and space complexity would also be the same because we are using two hash maps. So let's just check the code of this solution.
So this is the valid anagram problem 242, and solution 1, where we are just using the direct sorted function, inbuilt function. So what we can simply do is we can just use the sorted S. Okay, so we are simply going to sort both the strings and just compare if sort of S equals to sort of T. Then we are going to return true, else we are going to return false. Right. So this is what we can do. This is one of the solution. Okay, we can run. So this is accepted solution. All right, so this one is accepted. Okay, so this is the solution. So by default, sorted function basically by default Python uses stem sort, and the time complexity is O of n log n, and the space is O(n). So this way we are going for a second solution by creating the hash map and reducing the time complexity from O n log n to O n, or let's say OS plus t, wherein where s is the length of the string s and t is the length of the string t. Though the S and T string would be having the same length if they are valid anagrams. So let's uh, check the second solution, how we are going to do this. Okay. So first of all, what we are going to do is we are just want to we will first check the length of both the strings. If if the lengths are not equal, definitely then uh, it's not a valid anagram. So okay, all right. So just check this and just return false. If both the strings are of having different length, then we are just simply going to return false, and then we are going to create the hash maps of string s and string t. Okay. Now what we are going to do is we are going to iterate to any of the string. Let's say we take s string and we are just iterating to one of the string. Then what we are going to do is, actually we are creating a hash maps. So what we are going to do is we are just uh, as we are getting each character, we are going to count each character. All right, so we are simply going to count each character. So let's say but what will happen now, this will, since let us suppose we do not have any character yet in the hash map. All right, so this might give you a key error. Therefore what we are going to do is we can get around this problem by using get function, and we can use the get function over here. So it will take another argument as 0. So what it will do is, like, if we do not if the hash map has not yet got this character, then it will by default consider the value 0. So we will not we will not get the key error over here. So that's why we are using this function. All right, similarly we will create another hash map for our t string. So let's just name it as this. Okay. All right. Okay. So the hash maps are created. Just, all right. So now when we have created our hash maps, we just need to iterate through one of the hash map and compare each letter of the first hash map with another hash map's letter and their count. So simply iterating through each character of the hash map. Let's just take this. All right. What we are going to do is we are going to simply check the value of it, whether the key uh, values of the keys are equal. If not, then we're going to return false. Okay. So basically what we're doing over here is we are just checking each key values, and we are just checking the values of in both the hash maps. All right. Okay. So if we do not face if we any of the letter is not having same values in another hash map, then it simply returns false, because that won't be the valid anagram. All right. So but this again might give you the key error, since one of the case might happen, like the character we are looking in the another hash map, it might not have that character. Then this will give you a key error. Therefore we are going to again use the get function over here and simply use this function, and it will return 0 if that key is not found, and it will return false. So yeah, so we can go this way and we can return true if all the conditions are met. and we can say then uh, that is a valid anagram. All right. So this is the possible solution. Okay. Let's all right. Let's run this solution and then check. Uh, I have made some mistake. Okay. Hmm. It is accepted. So let's now submit it and check whether all test cases are yeah. So it has accepted it. So that's how we can solve this valid anagram 242 problem. Thank you so much. Please stay tuned for more updates.